Welcome back to Bal Vigyan Bharti with your mentor Abhilash Sarkar. So I will move on to the problem number 9 in binomial theory in this chapter. The problem number 9 says if the second, third and fourth term in the expansion x plus a whole to the power n are 240, 720 and 1080 respectively, then find n. Okay, so let me expand the series and accordingly I will equalize the terms. So x plus a whole to the power n is equal to x to the power n c0 plus c1 x to the power n minus 1a plus c2 x to the power n minus 2a square plus c3 x to the power n minus 3a cube and so on, because I required only second, third and fourth term, so I need not to write other terms of the expansion. So now I will equalize c1 x to the power n minus 1 into a equal to 240. Now I will further make it is simpler. So nc1, so that means equal to n minus 1a is equal to 240. This will be my first equation. Similarly, if I break into the simpler form, nc2 that is equal to factorial n by factorial 2 into factorial n minus 2. So now if I further reduce, this will become n minus 1 by 2. So I will write it n in n minus 1 by 2 x to the power n minus 2 a square. This is equal to 720. And the third one similarly will be nc3, that will remain as n minus 1, n minus 2, and factorial 6 means factorial 3 means 6. So this is equal to x to the power n minus 3 a cube, that will give you 1080. This is my third equation. So the thing that will come here, by doing 2 by 1, I am just dividing 2 by 1. So what will remain, if I see it, n minus 1, 2 will become here, or this term, n will come there. I am talking about the coefficient. What about this? The thing will remain at the top, a and a will cancel out, I will get a only, and this will be x n minus 1 divided by x n minus 2, so x will remain at the bottom. And if I divide 720 by 240, it will be something 3. So now further I can reduce, so get n will be cancelled out, so I can remove it and 2 will be there. So this is my fourth equation. Now doing 3 by 2, what I will get, n minus 1, that will be cancelled out, n minus 2 will be there at the top. Now this 6 in the denominator, 2 will go up, so there I will get 3 at the bottom, and similarly this a will come at the numerator. Here out of this 2, x will come there, and there if I reduce 1080, now I will show you here 1080 by 720. So 00, this is by 12, this is by 6, further 3 and 2. So the thing will remain here 3 by 2. So further this 3, I can make it easy further to get it. I will make it further easier from a by x. If I want to equalize this, so the remaining thing has to be transferred to the right hand side. Similarly, n will go up, so this will give you 9, and this n minus 2 will go there, so this is 2 into n minus 2. Understand, this will be there, so I can remove it from the list. Now both side a by x I can equalize. So if I equalize, I will get 6 n minus 1 is equal to 9 n minus 2. Okay, now this can further be reduced to, so ultimately 2 into 2 4 n minus 8, there 3 into n minus 3. So ultimately n will come there, so n will remain, I can leave it like this, and 8 will go there. So ultimately your answer is 5. So value of n is equal to 5. Okay. The next problem is number 10. The fifth term from the end, in the expansion x cube by 2 minus 2 by x cube whole to the power 9 is what? Now for that we have learned some theory where any term taken from the last, and if I want to convert it into the term from the first position, it will be, if it is t5 from end, then from front the term will be how much? The term will be, let's say tr, that will be the total power n. The formula was n minus r plus 2. So n is 9 here, minus r the term that is being counted from the end 5, and we will add 2 to get 4. So 6th number in the total expansion. So tr is equal to t6. So t6 of this series can be achieved by, if I say we are counting from t0, if not, if I count from the t1, then t6 will be the fifth term. So the coefficient will be c5. Okay, either or, if you count from the t0 also, that count will be c5 will get, and either if you count from the t1, so this will be treated as per your convenience tr plus 1. So this will contain, if I treat this is tr plus 1, so r will be 5 here, so c5, and the power of the first term will be how much? X cube by 2 whole to the power 9 minus r, that is 5, and the second term will be minus 2 by x cube, straightway that r, that means 5, isn't it? So this will be the term look alike. So if I cancel, this is 9c5. So 9c5, if I calculate factorial 9, factorial 4, factorial 5, or the reverse way you can write factorial 5 first, 9 minus 4, 9 minus 5 is equal to factorial 4. This is x to the power cube whole to the power 4. So x to the power how much? 4, 3 into 4, 12, and this is 2 to the power 4, that means is equal to 16, into minus 5, that means that the term will ultimately carry minus, because minus whole to the power odd, that will give you minus ultimately, and the remaining is 2 to the power 5 here, that means 32, and x to the power 3 whole to the power 5, that means x to the power 15. Now this can be simplified. 9 can be written as 9 into 8, 8 into 7 into 6, then factorial 5 will cancel each other. 4 can be expanded into 4 into 3 into 2. 1 I am not writing, okay, let me write. And this power 16, 2, so 2 will come here, and the ultimate power of x will be x cube. And if you cancel it, 8, 2, and this is 6 now. So 3, 2, 2 will be cancelled out. So 9 to the 18, 18 18, so ultimately 9 into 2 to the 4 into 7 into 4 at the top, this will all cancel and is equal to x cube. Now 63 by 4, 12, 25. So this will be 252 by x cube will be the term if I expand it in the way that is needed. So first thing, the concept is any term count from the end. If I want to count it from the beginning, from the front, that will be n minus the term that is being given here, the number of terms given from the end, that number plus 2 will be the count from the first. Now this, once I will get r, the r is equal to how much? 4 plus 2, 6. Now T6 I have to get. So T6, if I want to equalize with r plus 1, so r basically has to be understood what would be the coefficient here. Okay, so to understand that, if I split it into r plus 1 and 6 plus 1, or in my terms, if it is T0, so 6 will be 6 and there automatically it will reduce 1 because I am starting from C0. So the 6th will be T5. So, or otherwise don't be complicated, the way that everybody is understanding. So T r plus 1, so I split it r plus 1, so that means 6 plus 5 plus 1. This will be split it as 5 plus 1. So then it is easy to get the, because the common term will be NCR x to the power n minus r and y to the power r. So this is the common form of any binomial term. So this is when r plus 1 we are taking as a r plus 1th term is being represented as this. So in this way you can expand the series. Okay. Now move on to problem number 11. The term independent of x in the expansion of root x, whole root of x by 3 plus 3 2x square whole to the power 10 will be what? Means you have to find the term which does not carry any x if I expand it. Okay. So don't be very much in fear, because ultimately let us take the term without x is t r plus 1 term. So my easiest way to get a common term in terms of r. Now if I say this, in this series t r plus 1 will be the term without x, so t r plus 1 term will be how much? N C r means here I will get the coefficient r, and the term that I will get this whole power of. So expanding this, the first term will be under root of x by 3 whole to the power 10 minus r, and the second term will be 3 by 2 into x square whole to the power r. So this will be the total case. Now let me simplify this, and x to the power, so I can make it separate by keeping x to the root 3 whole to the power 10 minus r there, and there x to the power, this will be 10 minus r by 2 under root. So x for this term, the second term this will be 3 to the power r and 2 to the power at the bottom, and x will be 2r. Okay. So now first intention is to get the whole power of x. So let's say I am saying this is the total coefficient which is constant is a, and the power of r, if I am to calculate, r by 2, and this will come as negative 2r. So 10 minus r by 2 minus 2r, this power, as per the condition, as I taken that this is without x, so that means the power of x will be 0, then only x will be 0 will become 1, so there will be no x. So the total power as per this expression is 10 to the power 10 minus r by 2 minus 2r, that is equal to 0. So now from there we can solve it to get the value of r. So this is 10 is equal to 5r, so r is equal to 2. So now once I get the r is equal to 2, the term independent of x, I have to get the value of r, because this will become automatically 1, sorry. So this is without. Now my intention to get value of r. Now value of a is how much? 10. C, r I have already found 2, and this 1 by root 3 whole to the power 10 minus r, so that means 3 to the power 10 minus r is equal to 8 by 2, so this is equal to 4, and the remaining term here is 3 to the power 2, and there is 2 to the power 2, because all r value I have got. So everything if I put the constant will be, so there it is 10 into 9 root, if I expand it, 10 factorial at the top, 8 factorial, 2 factorial, so 10 into 9 and by 2 this, and 3, this will be 3 square and 2 square, that means 6 square, so that means 36. Okay, now if I reduce, I will get 5 here, so that means 45 by 36, further can be reduced by 9, 5 by 4, so this will be an answer. The term without x, that means r plus 1 I have taken, so 2 plus 1 is third term, and the value of the third term will be 5 by 4 will be your answer. Understood? Moving to next problem, that is problem number 12. Okay, the coefficient of x to the power minus 7 in the expansion of ax minus 1 by bx square whole 11 will be how much? Okay, so this is the task. Now this is just similar to the earlier problem. Now what we will say, let it be tr plus 1. Okay, now tr plus 1 in this series, what will be the case? It will be the whole power is 11 cr, and the first term is ax whole to the power 11 minus r, and the second term is minus 1 by bx square whole to the power r. So now once I will eliminate all the constant part on one side, so a to the power 11 minus r, and here 1 by b whole to the power r. So x will remain as x to the power 11 minus r, and this minus I have already taken with the b, so this x will be x2r, so this will be deducted from there. So now ultimately x power is this, so this power that I am getting with this from this expression has to be equalized with minus 7. So this 3r is equal to 18. So r is equal to 6. Now once I will get r, so the term will be t is 6. So seventh term. Now put the value here. R a to the power 11 minus 6, that is equal to 5, and here 1 by b whole to the power 6, and remaining you know what is this. So the term will be 11 into 10 into 9 into 8, factorial 7 will be cancelled out, and 11 minus 4 factorial 4 will be there, 4 into 3 into 2 into 1, and this will be minus b whole to the 6, that means it will plus. So this will be b to the power 6, and here it is a to the power 5. So what is the reduction from 8 to, this is 3, 3 is a 9, 2 will be cancelled then. So this is 11 into 10 is equal to 110 into 3, 330. So ultimately this will be 330 into a to the power 5 at the top, b to the power 6 at the bottom. So this will be the term look alike. Along with that, x to the power minus 7 will remain. So this will be the result of the sum. So I will end up here. In the next video, I will move on to problem number 13. Okay. So thank you for now.